Question number 5 says that find the perimeters of triangle ABE and the rectangle BCDE in the given figure, and we have to find out whose perimeter is greater. So we see that in the given figure we have been given with the side lengths of the triangle ABE, and we've also been given with the side lengths of the rectangle BCDE. But we see that few of the lengths are in the form of mixed fractions, so we'll have to convert them into improper fraction first. So 2 3/4, if we convert it into an improper fraction, will be 4 times 2, which is 8, 8 plus 3, which is 11. So this will be 11 over 4 centimeters. And similarly, 3 3/5 centimeters, if we convert it into an improper fraction, that will be 5 times 3, which is 15, 15 plus 3, which is 18. So that will be 18 over 5 centimeters. Now, what we have to do is to find the perimeter of the triangle ABE first. Now, by perimeter, we mean the sum of the lengths of a figure which enclose that figure. That is the length of the boundary. For that, we'll be writing the perimeter of triangle ABE to be equal to the sum of its 3 lengths, that is AB plus BE plus EA, and we'll substitute the values. So for AB the length is 5 over 2, for BE it is 11 over 4, and for EA it's 18 over 5. You see that these are unlike fractions because the denominators for all three of them is different, so we'll have to convert them into like fractions. The LCM for 2, 4 and 5 is 20. So what we'll have to do is to make the denominators for all of them as 20. To make the denominator for the first fraction as 20, we'll have to multiply the numerator and denominator with 10. So we get it as 50 over 20. For the second fraction, to make the denominator as 20, we'll multiply the numerator and denominator with 5. So we get it as 55 over 20. And for the third fraction, which is 18 over 5, to make the denominator as 20, will multiply the numerator and denominator with 4. So we'll get it as 18 times 4 divided by 5 times 4. So that gives us 72 by 20. Now that we have got the denominators same for all of them, we can just simply add the numerators. So adding 50, 55 and 72 gives us 177 over 20 centimeters as the perimeter for the triangle ABE. Now the next part is to find the perimeter of the rectangle BCDE. The formula to find the perimeter of a rectangle is 2 times length plus breadth. So the length of the rectangle BCDE is BE, whose value is 11 over 4. And the width is 7 over 6 as given in the figure. So we'll just add these two. But before we add, we again see that these two are unlike fractions. We'll have to make them like and then add. So to make the denominator same, we'll take the LCM of 4 and 6, which is 12. To make the denominator of the first fraction, that is 11 over 4 as 12, we'll multiply the numerator and denominator with 3, and so we'll get it as 33 by 12. And to make the denominator for 7 over 6 as 12, we'll multiply the numerator and denominator with 2. So that will give us 14 over 12. So we add 33 and 14 and divide it by 12. So 2 ones are 2, 2 6 are 12. And that gives us the perimeter of the rectangle BCDE as 47 over 6 centimeters. So now what we have to do is we have to compare the two perimeters, that is 177 over 20 and 47 over 6, and find out which is greater and which is smaller. But again we see that these two fractions are unlike because the denominators are not same. So what we'll do is we'll try to make the denominators same. So for the first fraction, we'll multiply the numerator and denominator with 3, that is 177 times 3 divided by 20 times 3, and that gives us the fraction as 531 divided by 60. And to make the denominator for the second fraction, which is 47 over 6 as 60 itself, we'll multiply the numerator and denominator with 10. So that is 47 times 10 divided by 6 times 10. And that gives us the fraction as 470 divided by 60. As we know that 531 is greater than 470, we can clearly say that 531 by 60 is greater than 470 by 60. So the perimeter for the triangle ABE is greater than the perimeter of rectangle BCDE. So here we write that triangle ABE and BCDE. The perimeter for triangle ABE is greater than the rectangle one. And this is how we solve this problem.
To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.